Hello everyone. Today I'm going to talk about the basics of machine learning and some very simple examples and situations where we might want to use machine learning or how machine learning can potentially help us as humans, as a society, as a race, just as a group of people trying to achieve a greater good. Okay, so let's start with supervised learning. And supervised learning is an algorithm that takes in an input to give us an output, or takes in X to give us Y. And this sounds like a lot of jargon right now, and I assure you it's going to get simpler. I'm going to give you examples to make this much more reasonable to understand and much more simpler to understand, so that you can really wrap your mind around what machine learning is, because it really is quite simple. So using this approach, what we're effectively doing is allowing the model to learn and generate a reasonably accurate prediction or output based on new input. So for instance, let's consider the case of spam emails. By providing a machine learning model with 5,000 emails that are correctly labeled as spam or not spam, it can learn the characteristics, the sort of patterns, and all the things that constitute a spam email and predict whether a new input is spam or not with a reasonable degree of accuracy. So in the beginning, we're basically giving this machine learning model, we're giving it an X, which is the email itself, and we're also giving it the Y, which is whether this X, the email itself, is spam or not spam. So we're giving it the answer, right? We're giving it the label that is correct. And we typically give the machine learning model a high number of these X and Y labels, inputs and outputs, so that we can get a more accurate machine learning model. Okay, and another example of supervised learning is regression. And regression would be useful, for example, for predicting sales for street vendors. So if I owned a ice cream store and I noted down the temperature, the average temperature every day for 1 year, and also noted down the sales, then I would get lots of data about the sales and the temperature, right? So now I can feed that data into a machine learning model, and with a reasonable degree of accuracy, the machine learning model, we can expect it to predict our sales based on our X, which is our temperature. So now I can give this machine learning model a completely new temperature it has never seen before, maybe something crazy like 75 degrees Celsius. And I can give it to the machine learning model and I can say, hey, this is the temperature today. How much am I going to make? Now, of course, this isn't going to work in real life, because if it was 75 degrees outside, we would probably all be dead. But this is what linear regression aims to achieve. It aims to make a prediction based on what it's seen before, and also its X and Y data that we've seen in the past, which is X would be our temperature and Y would be our sale data, or our net profit for the day, or our gross income for the day, however you want to phrase that, right? So in addition to regression, there is also classification, and classification is also a subcategory of supervised learning. An example of classification is breast cancer detection. So a tumor can be classified as, I know there's more types of classifications for tumors, but just to keep it simple, can be classified as malignant or benign based on its size. Right? So unlike regression, classification aims to predict a small number of outcomes, such as predicting whether a picture is a cat or a dog, a human or a monkey, a wizard or a witch, these types of things. Okay, so it hasn't got an infinite number of outcomes like linear regression. It has a very small and finite number of outcomes, and that's why we call it classification. So to summarize, we have supervised learning, which maps an input X to an input Y or to an output Y, and the model learns from the right answers. And the two main types of supervised learning are regression and classification, with the regression having a potentially infinite number of outcomes and classification having a smaller and finite number of outcomes. In unsupervised learning, we have a technique called clustering, which is used to find groups or patterns within the data without using any predefined labels or outcomes. So we're just feeding it X, we're not giving it any Y. There is no why, we're just giving it the raw data, and the machine learning model will try to find some pattern, some meaning to the mess that is the data, right? So for example, if we have a data set containing information about customer purchases at a grocery store, we can use clustering to group similar customers based on their purchasing behavior. And this could help stores to tailor their marketing efforts to different types of customers, different demographics, different types of people who walk through the store, and different customer segments, which, as we all know, or perhaps you don't know, is very important to marketing and to the bottom line of many retail stores. So clustering can also be used to identify common pairings of food items or common pairings of drinks in a restaurant, which would be really valuable data to have as an up-and-coming restaurant. You have this really, really big menu and you're trying to find out which items commonly go together so you can make some sort of a combo meal or some sort of set menu that would be more attractive to your customers. Well, unsupervised learning would be great for that kind of use case, right? We can also segment customers based on their behavior, such as identifying trends between one-time customers versus returning customers. And unlike supervised learning, unsupervised learning does not have any output or Y labels, as I mentioned before. The model tries to find patterns in the data without any prior knowledge of the desired outcome, because there really isn't a desired outcome, right? We're just trying to find some sort of pattern in the data. We don't know what this pattern is going to be, because that's why we're using unsupervised learning. Otherwise, if we knew what we were looking for, we would surely use supervised learning, right? So in addition to clustering, we also have things like anomaly detection, where the model identifies data points that deviate significantly from the expected patterns, right? There's also things like dimensionality reduction, which is something we can use to reduce the complexity of our data set or our findings so we can simplify analysis. But that's a whole nother topic in and of itself, so we're not going to touch that right now. And that's basically what machine learning is. So we've gone through our supervised learning and unsupervised learning. There are other types of machine learning, but these are the two main types. And in the next video, I'm hoping I can go in a bit more detail about some of these different types of machine learning models and hopefully build one with you together. And you can see how easy it is to implement a machine learning solution for yourself in your daily life and make your life 10 times more efficient, which is always the goal, right? Yes, hope you guys enjoyed this video, and I'll hopefully see you in the next one. Yes, so goodbye.